All right, trig. We're going to do basics of trigonometry. So over here on the side, I'm going to write our basic trig functions. They are sine. Let me make that smaller. It's still too big. There you go. All right. Sine, cosine, and tangent. And for this particular lesson, we're going to look at using these values all in the context of right triangles. So there are a few things that we need to know here. First of all, when you're doing these trig functions, they are set up using a ratio. Now, we've been doing a lot of proportions. A ratio is just part of a proportion. So when you do sine, so sine of an angle is equal to what is known as opposite over hypotenuse. Cosine, I'm going to abbreviate here, just use COS. Cosine of an angle is adjacent. We've talked about the word adjacent before. Adjacent means next to, over hypotenuse. And then tangent, again I'm going to abbreviate, tangent of an angle is opposite over adjacent. Now, what some teachers teach, and I do this a lot too, is an acronym to remember this, and it is called SO. Oops, let me rewrite that there. SO. TOA. Okay, and what that is, hopefully you follow this here. S stands for sine, O stands for opposite, H stands for hypotenuse. Okay, so when you're looking at those letters, they're just an acronym to help you remember the ratio that you have to write. Okay, so cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So it's just a means of remembering the ratios here. So that's what we're going to do in these first two problems, is we're going to find these ratios. So if we take problem number 1, tangent of z. Now, one thing you notice here about z is a capital letter, and we've said this before, capital letters represent angles. So it says tangent of z. Tangent is, so I come back down here, opposite over adjacent. So from z, the opposite side is the one across from it. So that is 5. So I'm going to label 5 here using a pencil, and I'm going to put here opposite. Now, adjacent is the side next to z. Well, if you look here, z has two sides right next to it, 12 and 13. But 13 is always the hypotenuse because it's across from the right angle. So one thing to get in the habit is always to label the hypotenuse. It's always the one, again, that's across from the right angle. So in this particular case, 12 is the adjacent side. So we write our ratio opposite over adjacent. And there's our answer. Okay, let's do problem number 2, cosine. Cosine of z. So the first thing I'm going to do is I'm going to label my hypotenuse. So that's across from the right angle, so that's my hypotenuse. Okay, so we look at cosine. So we come back over here. Cosine is adjacent over hypotenuse. So from angle z, I need the adjacent side. Well, again, there are two sides next to z, the 36 and 39, but 39 we've already labeled as the hypotenuse, so this is the adjacent side. So in this case, 36 is the adjacent. Now we write our ratio. So that would be 36 over adjacent over hypotenuse, 39. Now, one thing you should learn to do is reduce. So 3 goes into 36 12 times. 3 3 goes into 39 13 times, and that would be our ratio, reduced or simplified. Okay, the next one's says find the value of each trigonometric ratio to the nearest 10,000th. Okay, what's that mean? That means all you do is just type this in on your calculator. Now, one thing to be aware of, when you do the calculator, okay, and you press mode, there is what's called radians and degrees. And because these are measured, these angles are measured in degrees, make sure your calculator is always put in degrees. Okay, so once you've got it in degrees, you just go back to the main screen, you find sin or sign button on your calculator, you type in 55, and you get, it says to the nearest 10,000, so tenths, hundredths, thousandths, 10,000ths, that would be 4 decimal places. So I'm going to write here that is 0.8192, because that rounds. Now what you can do is set the mode on your calculator to 4 decimal places and it'll do it. Okay, so then we do cosine of 8 and we get 0.9903. Again, it rounds. All right, the next ones want us to find the missing side. Okay, so how are we going to do this? We're actually going to combine problems 1 and 2 with problems 3 and 4. We're going to set up an equation with this. Okay, so here's the angle we're going to use, the 58. Now from the 58 we have 2 sides. This one is the hypotenuse, because it's across from the right angle. And then from 58, this is the adjacent. Okay, so we go back to our ratios here. So I'm going to shrink this back down. Let's go back to our ratios. Which one uses adjacent and hypotenuse? Well, that would be cosine right here. Cosine's adjacent hypotenuse, or AH, adjacent hypotenuse. So what I'm going to do is I'm going to write an equation here. So I have cosine of the angle 58 is adjacent, which is my x, over hypotenuse, which is 17. Now what I'm going to do is I'm going to do what I did with the first 2. So the first thing I did was I set up my ratio like problems 1 and 2, once I knew it was cosine. Now I'm going to do this on the calculator just like I did up here. So I'm going to type cosine of 58, and then just like in the above problem, I'm going to go to the nearest 10,000. So I'm going to do point, that's going to be 5299 equals x over 17. Now I just solve for x. So I'll multiply both sides by 17. Those cancel. And this says round to the nearest 10th. Okay, so I do 17 times 0.5299. And to the nearest 10th, that's just going to round to be 9. Okay, now I'm going to do problem number 6. Very similar. So I'm going to erase this stuff in the middle. So I'll give you another second here. So now I'm going to set up problem number 6. Now the reason I got that in the middle because I want to use all this stuff over here on the side again to help me. So I'll look at this angle. Again, I'm going to label that is the hypotenuse. From this angle, this is the adjacent side. It's next to it. So I'm using AH again, which is cosine. So it's very similar to the one I just did. So cosine of 67 equals adjacent over hypotenuse. So I type cosine of 67 in on my calculator. I get 0.3907 equals x over 15. Then I'm going to multiply both sides by 15. Those cancel, so 0.3907 times 15 is Now to the nearest tenth, that's going to round to 5.9. You get 5.86. So there's your x. Okay, now let's do these last ones. It says find the measure of the indicated angle to the nearest degree. Okay, so we're going to do something very, very similar. The difference is we're trying to find the angle. So pay real close attention here. So here's my angle again. First thing I'm going to do, label my hypotenuse. So there's my angle. That is my hypotenuse. Now from that angle, that is the adjacent side. It's the one next to it. So again, I'm using A and H, so that's cosine. But this time it's set up cosine of x, because I don't know what my angle is adjacent over hypotenuse. So now what I'm going to do, since I'm trying to find the angle, I've got to get rid of this cosine. And here's how you do this. So just like when you're solving a basic equation, if you have 5 times x, to get rid of it, you divide. You do the opposite. Well, the opposite of cosine is what's called inverse cosine. And this is an actual part of your calculator. So what I do is I do inverse cosine on both sides. I do inverse cosine of 13 over 41. Now what's going to happen on the left side is these are going to cancel each other out. What I do on the right side is I type this in on the calculator. Now the way you do that is, I'm going to write these down. You have to press the second button on your calculator and then press the cosine button. And that will give you the inverse cosine. So you press second cosine, then you type in your fraction. 13 divided by 41 and press enter, and we get 71.51. Now since it says to the nearest degree, that means I'm actually going to round this to 72 degrees. Okay. Again, I'm going to give you a second here, then I'm going to get rid of this stuff in the middle so I can do problem number 8. Okay, so in problem 8, again, here's my angle. This is the hypotenuse. Sorry about that. And then from this angle, this is on the opposite side. Okay, so it's not next to the angle, it's on the opposite side. So OH, so if I come back up here, OH is sine. So this time I'm writing sine of x is opposite over hypotenuse. So now I do the same exact thing I just got through doing. I'm going to do the inverse sine on both sides. Let's cancel. So I'm going to get x is, so I type second sine button, 2 divided by 6, and I get 19.4, so that would be 19 degrees. Okay, so quite a bit in this, but as long as you understand the basics, it's really not that hard. But hopefully you could kind of follow this a little bit. We'll work on this homework together in class.